Reliability and consistency. If the dates are never right when we know the age of the rocks like these, how can we be sure that they're correct when we don't know the exact date that the rocks were made? Here's one from John Morris, a quote. When the same rock is dated with more than one method, it often yields the different ages. In fact, I don't know two samples any place that come up with the same dates using two different methods. There's always more than a 5% error, and that's your standard deviation for accuracy in science. He goes on and he says, and when the rock is dated more than one time by the same method, it often gives different results. You take a sample in the same, just move over a little bit, do the sample again, and you get a different date. Where's your science? And yet they'll put these up as scientific facts. Here's another example, the problems of radiometric dating of two different materials in the same specimen. In 1993, scientists found wood from a tree buried in a basalt, that is a volcanic flow, 69 feet deep. The wood samples were sent to be carbon-14 dated. They showed it at 44,000 years. The basalt that surrounds it, they sent the sample in using potassium argon and measured it, 45 million years old. And it's buried in the same thing. Incredible. Let's use radiometric dating with carbon-14. There's major problems for the old Earth. Carbon-14 has a half-life, as we stated, of only 5,700 years. It can be only used up to 100,000 years for accuracy because you only start off, what it is, it's incorporated from the atmosphere and when things are alive, and then it begins to die, begins to decay, that ratio, but it only starts in 1 part per trillion. So after 15, 17 half-lives, which is 100,000 years, you can't even measure one carbon-14 atom. Carbon-14 can only be used to date organic matter. You can't use it for inorganic. Carbon-14 accuracy is dependent upon a consistent ratio of carbon-12 to carbon-14 in equilibrium. We know that that's not true because we've dated trees, bristlecone pines and others, their rings, and compared it to the carbon-14. And from today back to the time of Christ, it's fairly accurate with a random variation. From then on, by the time you get to 1500 BC, you have 100% error. It meant that the atmosphere was not in equilibrium to maintain this because it's produced in the upper atmosphere, brought down, and so the amount coming down has to equal the amount that's decaying off. That has to remain as a constant. But the atmosphere was not in equilibrium. There's the assumption, this assumption of equilibrium is false. These are factors that could affect CO2 in the atmosphere, for instance, during the Genesis flood, or the canopy as we talked about. Ancient fossils, such as coal, they are supposed to be 250 million years old. They shouldn't have one atom of carbon-14 after 100,000 years, and yet they all date. And they're not contaminated from the air. These are things that are taken from deep in the earth and protected so they can't get contamination, and all of them have carbon-14 in them. Diamonds, they're supposed to be 1 million to 3 million years old. They're made of carbon totally. They're the hardest thing known to humans. And they all have carbon-14 in them, dating 50,000 years when they're supposed to be 1 billion years old. The problem with the radiometric dating, the fallacies are the starting amount of the element, of the daughter element, is unknown in almost every case. All of the daughter elements, that's even in the isochrones, all the daughter elements is not due to radioactive decay. It starts off, almost all these elements, for instance, uranium and lead, they have the same physical properties, so if you put them through a lava flow, they come out together. Rubidium and strontium, you find them together. Just like gold and silver. You find them together because they've got the same physical properties. So in a geophysical changing, they'll all be found together. So you don't start off with zero. So you'll find lead in uranium deposits. You'll find strontium and rubidium deposits. And strangely, you find argon and potassium, even though it's a gas. The sample was never in a closed environment. At any time, none of these are kept in closed environments. They've all gone through geophysical processes of some sort. The decay rate is not always constant, even in nature. Here you have potassium going to argon, again, the parent going to the element. The false assumptions in radiometric leads to false dates. If you base your theory on wrong assumptions, all of your work may be correct, but the result will be wrong. You can be very careful in how you're measuring the radioactivity, but if you don't start off with a good sample or your assumptions are wrong, you'll never get the right results. That's why when you date two systems, say rubidium and strontium and lead and uranium in the same deposits, you never arrive at the same date. There are always more than 5% deviation. Light speed. Now this is where we get another deal. This is for dating not the age of the earth, but the age of the universe. Einstein's theory of special relativity with a fixed speed of light poses a very great difficulty for, one, biblical believers in the young earth and universe, and it also creates problems for the Big Bang proponents of an old universe. In fact, it creates more problems for them than for us. Let me show you why. Starlight, for a creationist, if it travels at Einstein's speed from distant galaxies, would nearly eliminate a young, credible universe possibility. For instance, if the most distant galaxies, that light is coming in and it took 20 billion light years to get here, then how can the universe be 6,000 years old? However, look at the other problem. Conversely, it's impossible with the Big Bang for the distant galaxies to travel from the Big Bang out to their positions after the Big Bang and send starlight back to the earth. If they're out there and we can judge their distance out by how much of the field they take up. For instance, you don't need parallax to measure distance. If I see a man that's half as tall as the other one, I know he's twice the distance. So if I see a galaxy that's half the size of another one, I know it's twice the distance out. You could say, well, they're not all the same size. Let's take a statistical average and we can end up with that. In our deep field shots of the universe, the galaxies disappear into infinity. You don't see any end to them. And that's with the full power that we have. But so it presents problems. How with the Big Bang did it travel out there and then send us starlight back in less than 40 to 50 billion years? It won't last that long. And it would have to travel at the speed of light to get out there. And it can't do that. They've got a big problem too. How do they resolve these things? The Big Bang components, they created X and helio, a superinflationary theory. They said in the first fractions of a second, the universe blew out to this huge size and then slowed down and began to creep out. Do you know what the problem with that is? It violates almost every law of physics we know. How do you accelerate that much mass and then slow it down again? It's not possible. It becomes absurdity in the laws of physics. But they create it and say that's the way it's happened. Do you know why? Because it's got to fit into their theory without God or creation. What do the biblical proponents how do they deal with this starlight problem? Some, they say, well, okay, the universe is 13.7 billion years. God set it in motion, and it's just like a billiard ball game. They just all came to place and afterwards. They still believe in a 13 billion year universe. They're basically Big Bang components with God at the starter. You have another deal of old universe. and this is evolutionary theism, theistic evolutionists, and they believe, okay, we believe in a Big Bang, but God took it each step and brought it about to the present day. They're combining the naturalism and kind of a biblical approach, but they're throwing God in. Third approach is what we call an old universe progressive creationism. That's a guy like Hugh Ross, who thinks that the universe is old and that God controlled it, but at the very end, then he made man, Adam and Eve, and carried on from there. They don't deal with the problems of the day's age or death before the fall of man or anything. Theologically, it's a nightmare. Young earthers, how do they deal with it? Some say, well, the light was created in transit. See, the problem is, if Einstein's speed's true, Adam and Eve couldn't even see the first star for 4 years, the nearest one. And we'd never be able to see the most distant galaxies after only 6,000 years old. So they just say, God created in a transit. So when we saw the blow up of what's now the Crab Nebula in about 1050 AD, 1054 AD, but the distance is out there millions of light years, then they say, oh, well, God just created in transit. That event didn't really take place, but he just made it look like it did. A little bit of deception on God's part, of course, but that works in. You have the young universe with the speed of light decreasing with time. This is Barry Sutterfield and those who say that, the speed of light was much higher at the past, and then it slowed down to its present level. Well, there's no physical way that this is going to happen. The speed of light's going to change like that. They give no explanation of what's the physics of it. You have a young Earth with a time dilation on the Earth, so it's only 6,000 years here, but out in the universe it was 13.5 billion years. This would be Russ Humphreys and those people. They've combined relativity and young Earth creationism and come up with this. The problem is they've got it backwards, frankly, is the time dilation would take it place in the expanding frame and not on the Earth. The 13 billion would be here, and the 6,000 years would be out there in the expanded universe. What saves us from this dilemma? The master physicist, James Clerk Maxwell, derived the speed of light from his famous Maxwell equations 50 years before Einstein, which allows for a speed of light for a young Earth possibility, young universe. This is what his derivation is from his laws. C, in that case, the speed of light is equal to 1. And these they call them constants. They're not really constants. It's the permeability times the permittivity. All these are electromagnetic constants, or variables, I should say, that measure the strength of the electromagnetic field. For instance, in a diamond, these are very strong. The electromagnetic field is. What happens to the speed of light? Because these are in the denominator. It slows down. You know, the speed of light in a diamond is 1/2 of what it is in the air. Do you know why my glasses work? It's because the speed of light changes in the glass. It slows down and bends. These are stronger than air in my glass. If I have a glass of water and look in it, these are stronger than in the air, so the speed of light goes down. This work was done in the mid-1880s. It's 50 years before Einstein. It's contrary to Einstein's 1905 special relativity that fits the speed of light at 186,000 miles an hour per second, or 300,000 kilometers per second. The speed of light, however, varies according to his equation inversely with the strength of the magnetic fields. The speed of light will approach nearly infinite speeds in weak electromagnetic fields of deep space. See, these electromagnetic fields come from the charges in all matter, electrons, protons. Okay? So if you got a solar system like ours, it's strong. But as you move into space, those fields go out infinitely. And they become very weak. So what's going to happen to your speed according to Maxwell? It goes right through the ceiling. Now, there's no place in space that you have no electromagnetic field. So it can't go to infinity. The beauty of this thing also, too, is that if this is true, and it's time tested for 150 years, much longer than even Einstein, is that matter also can travel up to the speed of light. Now, if you raise the speed of light, the speed that you can travel can increase. So the Star Wars deal of Scotty, give her warp drive can be true. It's not true according to Einstein. You can't have warp drive. But if this is true, you could visit with the right propulsion units the most distant galaxies in your lifetime. And so light can come from those distant galaxies not in 20 billion years, but in a matter of a few years. Adam and Eve could have seen the 7,000 visible stars in today's sky on the sixth day of creation. Today, we can see the most distant galaxies with our most powerful telescopes. Since Maxwell's derivation is time-honored and true, the speed of light in deep space will approach nearly infinite speed. The light from the most distant galaxies will be only a few years old. In this case, the universe can be very young with Maxwell's speed of light. Here we're looking at what we call a deep field shot. They shot out, and there's only one star there in our galaxy. All the rest of these things are galaxies disappearing into the infinity. They get smaller and smaller and smaller and finally disappear out there. The question is this new or ancient light that we're seeing from them? Is it Maxwell or Einstein? Do we have a new universe or an old universe? Scientific evidence for a new Earth. There's a lot of them, but I just listed several here. You have isometric dating and nuclear decay rates, as we pointed out, indicate that we're looking at a very young universe. Carbon-14 ratio in the atmosphere in diamonds and coal indicates that it's young. Radio halos of polonium and helium. What happens when these things degenerate in granite, for instance, polonium? It leaves a distinctive burn mark around it called a halo. Well, these are some of the decay rates are in terms of seconds. Well, how did the granite cool with the polonium in there to leave the halo? It can't. It has to be below 450 degrees to leave the halo. And yet they're in the middle of the things. Also, you have a lot of helium in there. And the helium will go out through the wall because you have to have a very special container to contain hydrogen and helium. But there's too much of it if it was old. Sodium accumulation of salt in the oceans. Rapid disintegration of the comets. Erosion of the continents. There wouldn't be any continents if it were hundreds of millions of years old. Sediment in the ocean. It's very thin. Decay of the Earth's magnetic fields. Population statistics. We should have a lot more fossils of ancients than we do today, and we wouldn't be up to the size we are today if there had been, man had been around for even 100,000 years. The galactic spin. The arms in the galaxies, if they'd spun very long, they're just twisted. If they'd spun very long, they'd just be like the rings of Mars, of Jupiter and Saturn and Uranus. They'd be smoothed. They're not smooth. They've only been turning a certain amount of time. There are many more other things that indicate that we're looking at a young universe and a young Earth. Conclusions. Facts about the age of the universe. The universe has not been scientifically proven to be billions of years old. The Bible teaches a literal 6-day, 24-hour-a-day creation. Many scientists believe in a literal 6-day creation less than 7,000 years ago. There's new evidence from radioactive decay. I should add genetics also. Support a young Earth model. Maxwell's derivation for the speed of light supports a young universe. And there are many other scientific evidences for a young universe and a young Earth.